Monocular and binocular cues. The image of an object projected on our retina is two-dimensional. Even then, we see the world in three dimensions. This three-dimensional perspective of the world is a psychological process, and it depends on the appropriate use of the monocular and the binocular cues. So, before going to the details, please remember to subscribe this channel. Thank you. Let's see the definitions. The monocular depth cues. They are information about the depth that can be judged using only one eye. That is monocular depth cue. It can be used in pictures. So, a lot of monocular depth cues are used in art. For what? To give the viewers a sense of depth. Next is binocular depth cues. It is the information about depth that uses both eyes. In monocular depth cue, only one eye is used, and in binocular depth cue, both eyes are used to see and understand the three-dimensional space. This is a lot easier for our brain to comprehend than the monocular depth cues. Now let's see the types of monocular depth cues. First one is height in plane. Let's see the example of this picture. Here you can see the houses drawn. Those houses that are in the higher level, that appears far away, and those houses that are drawn in the lower level in this picture, that appears closer to us. So, the things that are on a higher plane, which is in the height, is perceived far away, and which is in a lower level is perceived as closer to us. So, that is the height in plane. Next is relative size. Consider this example. Here, two pencils are there. The one which is larger, which appear larger, it seems to be closer to us. And the other pencil which appears to be smaller, that we feel like it is far away from us. So, a bigger size image make us perceive that the object is closer to us, and the same thing with a smaller size will give a feel, or we perceive it as far away from us. So that is the relative size. Then comes occlusion. Here, when the objects hide another object, the object in the front that we perceive closer to us, and the object behind that we perceive as far away from us. Here we perceive triangle as closer to us than the square, and the circle, which is again overlapped by the square, it is perceived as far away from us. So that is occlusion. So when one image hides the other partially, then we feel like the hidden or the partially hiding thing is far away from us. Next is linear perspective. This is when two parallel lines come together at some point in the horizon. The closer together the two lines are, the far away they seems. For example, consider the road or a railway line. You can see two parallel lines here. Far away, you feel like these two parallel lines are converging. The rail tracks at the distance you feel like it will meet each other at some point. But in reality, we know that these are two parallel lines. But when the distance in a faraway place, you feel like this converges and it meets at some point. So this is the linear perspective. It says that the distance between two objects, when it is far away, it appears to be smaller than what the distance actually is. So if suppose it have a distance of 1 meter, then the same thing which is far away from us, we perceive it like there is only small distance between these two objects, these two parallel lines. When it go far away, we perceive it like the distance is coming less between these objects. So that is linear perspective. Now let's see the binocular depth cue types. First one is convergence. In order to present images of what we see into our retinas, the two eyes, it rotate inwards towards each other. When the objects are closer, the more the eye must rotate. So this is the example of a convergence. So if the object is very close to us, then what happens? You can see here both the eyes converge to see this image, to see this butterfly. Both the eyes converge. So when the object becomes closer, the eye must rotate. And the brain uses this information, that is the amount of rotation, as a cue to understand that how far is the object. By detecting the muscle differences the convergence causes in our eyes. So when we see an object far away, there won't be much convergence. So the brain detects this muscle convergence and then identify how far is the object we are seeing. Then comes the retinal disparity. When we see something, slightly different images of what we see are sent to each retina. We see with both our eyes, right? So each eye sent images to the retina. As our eyes are apart, each eye sees things from a slightly different angle. But we don't view the world as a series of two images. Our brain, it processes the small difference that happens or the disparity that happens. Our brain will process it, and the two images are assembled and one image we see with the depth, height and the width. The disparity or the difference between the two images allows the brain to calculate how far is the object is. An object close to us has a larger disparity or difference, and an object far away, it has a smaller disparity or difference. Example, in this image, this is seen by left eye and this is seen by right eye. So there is a difference. In the image you see with left eye and the one you see with right eye. Here the house between the trees are visible when you see with right eye, and here the house is not much visible. You can try this at home, closing one eye and viewing a certain image, and you can see the disparity. And this disparity or the difference is calculated by the brain to understand how far is the object from us. The difference between the monocular cue and the binocular depth cue, you already understand from the definitions and the types. But again, just in 2 points, we can see that the monocular cue uses one eye to process the distance. The binocular cue, it uses both eyes to process the distance. In monocular cue, it allows to see objects in 2 dimensions, but in binocular cue, it allows us to see the objects in 3 dimensions. That is, a better quality image is seen through the binocular cue. Now let's have a quick recap on what we have learned. We have learned the definition of the monocular cue and the binocular cue, then the various types with examples and the difference of these two cues. Hope you like this video. Please like, share and subscribe. Thank you and keep smiling.